The parallel plate capacitor has plate area 100 cm square and plate separation 1 cm. A glass plate dielectric constant 6 of thickness 6 mm and a bonite plate dielectric constant 4 of thickness 4 mm are inserted one over the other to fill the space between the plates of the capacitor. Find the new capacitors. So clearly, these two capacitances are connected in series. So we find C equivalent, that will be C1, C2 divided by C1 plus C2. So C1 will be equal to epsilon naught A times K1 divided by D1, and the C2 will be equal to epsilon naught A times K2 divided by D. We put these values here. So epsilon naught A times K1 divided by D1 plus, multiplied by epsilon naught A times K2 divided by D2 whole divided by sum of the two epsilon naught A K1 divided by D1 plus epsilon naught A times K2 divided by D2. Now we further simplify. CS will be equal to epsilon naught A times K1 K2 whole divided by K1 D2 plus K2 D1. Now let's put the values. 8.85 into 10 to the power minus 12 into plate area is 100 cm square, 10 to the power minus 4 into K1 is 6, K2 is 4, whole divided by K1 D2. So K1 is 6, D2 is 4 mm, 4 into 10 power minus 3 plus K2 D1. K2 is 4 into D2 6 into 10 to the power minus 3. Now we simplify it. So it becomes 8.85 into 10 to the power into, from here it will be 24. So we write it as into 24 times 10 to the power. We find the sum of all powers. So minus 12 minus 4, and from here plus 2, and from here this will be plus 3. This will be common. 6 4 is 24, 6 4 is 48 into 10 power minus 3, then minus 3 will go in numerator. So divided by 48. We further simplify, so we will get 4.425 into 10 to the power minus 11, which can be written as 44.25 into 10 to the power minus 12, or 44.25 picofarad, which is our answer. Now, let's go to next question. A parallel plate capacitor having plate area 400 cm square and separation between the plates is 1 mm is connected to a power supply of 100 volt. A dielectric slab of thickness 0.5 mm and dielectric constant 5 is inserted into the gap. Find the increase in electrostatic energy. If the power supply is now disconnected and the dielectric slab is taken out, find the further increase in energy. And why does the energy increase in inserting the slab as well as in taking it out? Here situation is shown. Here there is dielectric slab of thickness 0.5 mm. Total separation between the plates is 1 mm. So here there is air. Now let's consider first part, increase in electrostatic energy. So we have to find out capacitance first. So C1 is equal to epsilon naught A divided by D when there is no dielectric. So we put the values 8.85 into 10 to the power minus 12 into plate area 400 into 10 power minus 4 divided by separation, and that is 1 into 10 to the power minus 3. So if we simplify, we will get 3.54 into 10 to the power minus 10 farad. Now, when dielectric is inserted, in that case, capacitance will increase, and that will be given by epsilon naught A, D minus T plus T upon K. Here, D is total separation, and T is thickness of dielectric. So we put the values again, 8.85 into 10 to the power minus 12 into plate area, 400 into 10 to the power minus 4 divided by d minus t. So d minus t will give 0.5 mm. So 0.5 into 10 to the power minus 3 plus t. T is 0.5 into 10 to the power minus 3 divided by k. K is 5. So this will become 0.1 into 10 to the power. So let's simplify it other way around. So here we can write it further. 8.85 into 400 into 10 to the power minus 16. Here, this will become what we do. We multiply by 10 upon 10. So this 0.5 will become 5. So this 5 will get cancelled and 10 power minus 4 will be left. So 0.5 into 10 to the power minus 3 plus 10 to the power minus 4. Now further we simplify it. So on simplification, we will get 5.9 into 10 to the power minus 10 farad. Now increase in electrostatic energy. So final minus initial. So suppose we denote it as delta U. So half C2 V square minus half C1 V square. We put the values 1 by 2 into V square is common to both, that is 100 square times C1. This is 5.9 into 10 power minus 10. This is 3.54. So 3.54 into 10 to the power minus 10. So on simplification, we will get 1.18 into 10 to the power minus 6 joule. Now, consider the next part. If the power supply is now disconnected and electric slab is taken out, then so if power supply is now disconnected and dielectric slab is taken out, so further increase in energy we have to find out. So charge on capacitor when dielectric is there. So this we write it as Q equal to C. And this time we have to consider the capacitor. In the second case, when dielectric was there, so it was 5.9 into 10 to the power minus 10, and the voltage was 100. So it will become 5.9 into 10 to the power minus 8 coulomb. Now, when battery is removed and dielectric is also removed, then charge will remain same, and hence capacitance becomes C1 again. So we write it that V1, we are applying Q equal to CV. So V1 equal to Q upon C. Here C will be original one. Suppose we write it C1. It is the case when there was no dielectric. This is capacitance when there is dielectric. So Q is this much. So 5.9. Here charge is increased when capacitance is increased. So 5.9 into 10 to the power minus 8 divided by C1. So C1 means initial value of capacitor when there was no dielectric was 3.54 into 10 to the power minus 10. So that comes out to be 166 volt. Now potential is increased. So increase in energy. We find increase in energy. So it will be new energy minus new minus initial, final minus initial energy. So it will be equal to, suppose we write it as delta U1. So it will be half C times V1 square minus half. So C times, suppose we write it as C1 square, so C times V square. So here we put the values. So this is C1, this is C2. C1 is initial capacitance when there was no dielectric, and C2 is capacitance when there was dielectric. So it will become 1 by 2. C1 is 3.54 into 10 to the power minus 10, and voltage is now it is 166, so 166 squared minus 1 by 2 C2. C2 is capacitance when there was dielectric 5.9 into 10 power minus 10 times voltage squared 166 squared. So it will be negative. So it will come out to be negative because this value is smaller. It's 5.9. So negative of 1.92 into 10 to the power minus 6 joule, or we should write final minus here. Mu is final energy and initial, so this should have been written in the reverse way. This is negative, this is positive. So there is minus sign here, there is plus sign here. So ultimately there won't be negative sign. And we will get change in energy. Now, next part of the question is, it says, why does energy increase while inserting and removing the slab? In first case, we have seen that C changes to epsilon naught A upon D minus T plus T upon K. Since K will go in numerator, so it will increase the capacitance. Moreover, so since capacitance increases, so energy is related to capacitance. So definitely energy will increase while inserting the slab. When slab is taken out, in that case, what happens? Charge increases because capacitance increases. So charge remaining same. So this time, even if there is no dielectric, since value of charge is higher, so in that case also energy will increase. Thank you for watching.